Today is August 9th, 2022. It is a Tuesday. It is also day 387 of data science, and today I decided to go back into the plotting world of Python, and I'm going to be plotting two things. So the first one is a normal distribution with the mean of 50 and a standard deviation of 10, and then I'll plot the standard normal distribution, and then at the end I'll attempt to put both graphs together in a figure, which might cause a problem for me, but we'll come across it as we go. So first things first, I need to import NumPy because that's going to be the function. I'm going to use a function from that library to get my x values that I'm going to plot. To plot, I'm going to plot, let's see, matplotlib dot pyplot as plt. Did I say plot matplotlib? I meant import matplotlib. That's going to be my graphing library, and then I'm also going to import from scipy.stats the norm function, because that's how I'm going to get the values for the normal distribution. All right, so first things first, x values and y values, and then plt.plot, which comes from matplotlib, and I'm just going to plot the x values and y values, but I first obviously have to set what they're equal to. So I know that for the normal distribution, I want my mean to be 50, and then the standard deviation to be 10. And then for the x values, I'm going to do a NumPy function called linspace that takes in three parameters: start, stop, and then the values in between. So where do I want my graph to start on the x-axis? So I want it to start actually from the mean 3 times the standard deviation. So for this, it would be like, it would start at 20, and then it would end after the mean 3 times the standard deviation. So it would end, let's see, that would be 80, right? And then I want 1,000 values in between. And then for the y values, I'm going to do the norm.pdf function, which is a probability density function. And I'm just going to find the probability density of all of the x values, given that the loc, which is the mean, and the scale is the standard deviation. And then that should plot my normal distribution, which is literally so pretty. See, it starts at 20, ends at 80, because 20 is 3 times the standard deviation to the left of the mean, and then 80 is 3 times the standard deviation to the right of the mean. Okay, so I'm just going to make it a little bit prettier, so I'll do plt.title, call it normal distribution, and then let me go ahead and get the mu symbol, and then the standard deviation symbol. So I'll go ahead and copy the mu symbol and just paste that in there and call it, what was the mu, 50? And standard deviation, which is sigma, and that would be 10. Run that, and that should happen right there. And then I'll go ahead and add a y label. Oops. And I can call this proportion, density, area. Well, not necessarily area, but density and proportion would work. All right, and that's the normal distribution given the mu of 50 and standard deviation of 10. Now to plot the standard normal distribution, it's literally the same thing. I'm just going to copy everything, paste that in there, and just change the mean to be 0, and the standard deviation is 1. Changed it over here in the title as well. And then everything else literally stays the same. And it's just going to have an average of 0, and it's going to be 3 times standard deviation to the left, so that would be -3, and then 3 times the standard deviation to the right, which would be 3, right? Because, yeah. All right, and so that's the standard normal distribution. I should probably write that. Also, standard normal. And now here's the interesting part. So usually when I'm working with figures, it's easy for me to work with figures and plot them when I'm using Seaborn, because Seaborn has this like parameter axes, which lets you assign like which graph to assign the plot to within the figure. But I'm not sure how to do it with just a plt.plot one, which is kind of weird of me, right? Because that's the original. So first things first is creating the subplot. So plt.subplots, and so I want 1 row and 2 columns, and then the fig size, maybe set that to 10:4, maybe, question mark. Did I put, okay, let me get rid of that and run that. All right, so here's my figure. It's looking kind of okay, but notice that it returns a figure size, and it also returns 2 axes, and so I could actually set those variables, and I could just set figure, and then axes would be here, and I can label them and set them to variables. And so now I have a figure that I can control, and I can also control these two graphs. By the way, anything that is in the same row, you want to be putting in this in like one parenthesis. If there was like another row, then you would have just done another one, then you would have put like AX3 or whatever graphs that are in there. But this is so far what I have, right? Okay. So now, if I were to have made a graph with Seaborn, I could just set, put the graph in Seaborn and at the end just set AX equal to AX2, and then that graph would have gone to the axes 2. That's like graph 2. Um, but plt.plot doesn't have that, what do you call it? It doesn't have that option that I know of, right? So I'm not sure how to put these together in one plot, honestly, but I'm gonna try to figure it out. So let's see, I know that if I just put this one over here, it's gonna plot at least one, but it's not gonna plot both of them, which is the problem. So let's see, does plt.plot have an axes parameter? Let's look, let's do some research. All right, so let's see. Scale, data. Let me see, does it have an axis? Okay, nope, never mind. No. I already know that. Oh my god, what if I did this and then I just put in, I don't think that would work, would it? Like a whole, um, let's see. Oh, it's ax.plot, not plt.plot. Oh, so that's all I have to do? Okay, let me check. So if I were to just set the first plot to be, let's see, set that equal to, this would be the standard normal, so that would be ax2, and then this would be ax1, and then in that case, I would have to change the other stuff too. So that would have been like ax1.setTitle, because I believe it's different when I'm using ax. And then this would be ax1.set ylabel. Let's see if that works. And let me just put this line over here, just move it towards the top, and then just run that, and then run this one. Let's see. Set title, not a thing. Okay, let me bring this one down then. Interesting. Set title. So then would it have been title? Oh, it's not ax1, it's ax1.plot. And then set that equal to that. And let's try this one more time. Okay, this object has no attribute plot. Okay, let me go back up over here. Run that. Okay, let's see. So xfig add axes. So that's the figure. And then I can control the values. Huh. So I could do fig dot plot. See, AX is a set title. I guess that's for the figure. Let me see. So would that be fig dot plot? Would it make sense? No, would it? fig, fig, fig. Okay, so let's see. ax.plot. Let me just look into that. ax.plot. I was just here before. Okay. So I could do axes.plot, call signatures, and then plot whatever values here. That's the data. The coordinates of the points or line nodes are given by x and y. Optional is a convenient way for defining basic formatting like color, marker, and line style. It's a shortcut string notation described in the notes use section below. Let's see. So how will this end up working then? Let me go back. Okay, so I have a figure and then I have two axes, which are my two subplots, right? My graphs inside the figure. And then how would I target those? So wouldn't I just do ax1.plot? So ax1.plot, and then I can do ax1.setTitle. But then this would have to be, has no attribute plot, but it would if, it's so weird. I know this is not what I want. What is the difference between plt.plot and axplot? Let's understand the difference between plot, axes, and figure with an example. So plot, well, I know those are graphs. I know, but like, how do I target? Okay. So I have my figure, and then I have my figure, and I added a subplot, meaning I added a graph. Let's see, plt.plot, right? And then I can do that, blah, blah, blah. Drawing lines in the activated figure, and then I put in my values in here, and then plt.show. But what the? That's it? But I need there to be more, though. So it's like they're literally not using anything, which doesn't make sense to me, but okay. How about I get rid of this real quick? See, it doesn't even make sense. plt.plot is what I had in the beginning, and then this would have just been plt.title, and then this would have been plt dot, oops, y labeled. And I did look into the possibility of, of creating this graph with Seaborn. But the only thing that's close to it is like a KDE plot and a point graph thing, but a KDE is like a kernel estimate, a kernel density estimation, and it's not exactly the curve, which is a problem. So it's not like it's the same, and then the point plot is just weird. Like, look, I could try doing the same thing. I could do sns.pointplot. Let me see, sns.point. Hopefully I spelled it right. And then it would be x values and y values. And then weight. And then maybe I think there's a line width. Maybe I can do line width, set that equal to 2. Oh my god. 1. Are you serious? it still doesn't do anything. Isn't that great? So set that equal to x, set this equal to y. See, this is the problem. It's like not the same. It's like not visually pleasing at all. Like I don't know how to make a normal distribution graph using Seaborn because it's just weird. The only thing that it has is the KDE plot. Let's see. There's a disk plot, and then it has the kind, but it only take one value, and it would have the kind set equal to KDE. Oh God, Jesus, what is it now? Kind? Is it not kind? Is it just, I don't think SNS has a plot function, does it? This plot. There we go. See, it's just like not it, honestly. It's like literally kind of it, but also it's not it. So that's the issue. And yeah, so and then if I were to just to do this, all I had to do was set the AX equal to AX1, and then I would get it as my first what do you call it? My first plot. But so I guess this is a problem that I'm gonna have to figure out another day because it is really late today. I just can't seem to figure it out. This is interesting. I love challenges. Okay, so I guess for the summary for today is, first of all, there's lots of things that I maybe want to know. So first of all, is there, like, how would I plot a normal distribution using Seaborn only? Number two, if I plot a normal distribution using plt.plot with matplotlib, how do I put both graphs, like if I were to do two of them, how would I put both graphs into the figure? Interesting question. How about, what if I set that equal to AX and then set this equal to AX2? And then I were to just put it here and put this here. I don't know, I'm just making things up now. Let me see if that works. If not, then I'll leave it for a question for another day. C doesn't work. plt.plot. So then this would be, let's see, this would be the first one. And then this stuff would be for the second one. Oops, I did in the wrong thing. Yeah, that doesn't work. So AX, even if I change the graphs, even if I set them equal to something, it doesn't work. Interesting. AX dot, okay, AX plt dot plot, X values, Y values. I'll just ask Reddit, honestly. Let me ask Reddit. Actually, no, because then I don't want to show my account. Okay, never mind. I'll do this after the video. I'll ask Reddit and then we'll see what answers I get. But yeah, I'm not sure. Maybe it could be like the most common sense thing, and I'm just like missing it. It always is. It's like a semicolon, missing a semicolon type of deal. But no, it's just I'm missing context. Like I don't think it's just not giving. I don't know. Like what could I be? How do I do this? Like I mean, it's pretty logical. I feel like this is logical to do, right? Set it equal to. I know how to do it in Seaborn, just not with matplotlib, with just like simple plots. Because it doesn't have an AX value, which absolutely is so annoying. Let's see. Plotting multiple subplots in matplotlib. So I have ax.plot. Isn't that what I had? Like, hello. Right? And then axs. No, you're kidding me. I remember this. I think I had the same problem. Stop it. All I had to do, you're kidding me. Like, this is, are you serious right now? So I could have just had ax, and then this would have been ax index 1, and then this would have been ax2. Let's see if that works. Index 2 is out of bounds for axis 0 with a size of 1. Oh, so this would be, oops, I meant 1. Sorry. Okay, 0 and 1, and it still doesn't work. Okay, so let me know what the problem is here, because I would love to know. So ax1.plot, so it's not ax1, but it's dot plot, and then this would be dot plot. It worked! Oh my god, stop it. Stop. Whoa, that's crazy. And then, oh, I would have to reiterate these values here, because for this one it's 0, and this one is 1. Okay, I did it. Yes. Okay, let me cite this because you're kidding me. I remember doing this. I completely forgot. I cannot believe myself, actually. Like, I genuinely cannot believe myself. Like, how in the world, like, you learn something and then you just, like, I don't know, I've never experienced this before. Like, and you just completely, you're blind to it. Like, you just don't remember it. Like, oh my God. Like, I remember of it and I just completely forgot about it. That's I didn't even know of it. I completely forgot it was even an option. Like it's not just that it's not that I forgot how to do it, it's I forgot it was even an option. That's like so funny. Okay. So great. Oh my God, I figured it out today. That's great. So let's see. So at this point, let me just bring this a little bit down over here. And all right, let me bring this down also. Okay, so then now I can do the rest of it. Now I remember. So the rest of it is simply ax and then 0, and then I can set the title to be normal distribution. And then I have to just copy this over here. And then for me, that would be 50 and 10. And then I'll just go ahead and copy this line and just put it over here for 1. Make sure that's set to 1. And then set the title to standard normal distribution with 0 and then 1, and then run that, and then the title should be there. Perfect. And now for the y labels, I'll do, oops, that's the wrong thing. Okay, and then ax, and then what do I do again? 1 dot set y label, set that to density. Oh my God, this is actually a really, really good example, like when I'm like doing what do you call it? Like comparisons between like z-scores and like just using the normal distribution values. It's really super cool. All right, so that's what I wanted to do today. Perfect. It's beautiful. Honestly, I'm gonna go even a step further. I'm gonna go to Khan Academy and get one of these problems that I've been working on. Probably, it doesn't really matter. Let's see, maybe this one. All right, and I'm just going to plot the graph. So to put it kind of like in a context problem, or maybe should I do that tomorrow? Should I do that tomorrow? No, I'll do it today. Yeah. So I'll go ahead and, what? Rude. All right, let me just screenshot. Hello? It's literally not letting me screenshot. Okay. Is this thing serious? It's literally frozen. Oh, that's great. How about I just take yesterday's problem? And did I do one? No. Okay, so I'll just take yesterday's problem. So I'm just going to go ahead and copy this and paste that in here. And now what I'll do is I'll simply just read it. So A set of electric toothbrush prices are normally distributed with a mean of $87 and a standard deviation of $8. What proportion of electric toothbrush prices are between $104.60 and $108.20? So I can find this answer with NumPy. So not NumPy, scipy.stats. So from scipy.stats, I mean, I'm not going to find the answer because I did that yesterday, but what I could do is I could plot the actual graph. So I'll do the same thing. I still need to do from scipy.stats import import norm, and then I'll go ahead and import numpy as np as well, and then import matplotlib dot pyplot as plt. All right, and then I can just get started. So I'll do plt.plot my x values and my y values, and this is going to be my normal distribution graph with the mean of $87 and a standard deviation of $8, and then my x values, oops, and my y values. So my x values is going to be np.linspace, and it's going to be from the mean to the left of the mean, it's going to be 3 times the standard deviation, and then from the right of the mean, it's going to be again 3 times the standard deviation, so 87 times 3. And then I want 1,000 values in between. That's what my x-axis is going to look like. And then my y values are going to be norm.pdf, which is a probability density function. It's going to find the density of all of my x values, given that the mean, loc, is set to 87, and the scale, which is the standard deviation, is set to 8. Let me fix that real quick. And that should be my normal distribution graph. Okay, so now to get into a format of what do you call it, of a matplotlib figure, I'll just set that up. So I'll do plt.subplots, and I'm only going to have 2, so 1 row, 2 columns, and then the fig size, I'll set that equal to 10, 5 maybe. Let's see what that looks like. Okay, how about I do, oops, did not mean to do that. Let's do 12, 5. Okay, that's much better. All right, and then I'll set this equal to the figure, and then also to the axes. Set that equal to that. So those are the graphs, and then I'll go ahead and copy this code, and I'll just move it over here and set this to be AX instead, and I'll make sure it's the 0. So it's the first one, and if I plot that, that should go into the first graph. Perfect. So I'm just going to go ahead and now do the second one. So the second one would be literally the same thing, except that it's a standard normal distribution, meaning that the mean is 0 and the standard deviation is 1, and then everything else just stays the same, and just make sure that this one goes into the second one, which is indexed by 1. And so now this is going to be the standard normal distribution. The only difference is the axes, right? So you can see it starts at 0 in the standard normal, and it starts at 87. Not it starts, but in the average, the mean is at 87 in the middle. All right, now to make it pretty, I'll do ax0.setTitle and say, okay, this is a normal distribution of, and so in context, which is why I wanted to do a problem, it's about toothbrush prices. So toothbrush prices. With the mean, let me get the symbols again. Just go ahead and pick this up and come here and put this down over here. And then for this one, it would be 87. And then over here would be 8. And then for this one, let me just run it, by the way, so you can see it. This would be a standard normal distribution. Make sure it's 1 of toothbrush prices with the mean of 0 and the standard deviation of 1. And so now I can see the differences. Also, maybe to kind of make it a little bit better, maybe I'll just put a break in there in both of them. So that kind of goes to the next line. Okay. So That's looking good. Yeah. So it's the same thing visually, But then let's see, what else am I missing? The y label. So I'll do ax0 and I'll do set y label. Set that equal to, what am I setting it equal to? Density. Because I calculated the density, right, from the PDF probability density function. I calculated the density of all of the x values. Make sure I'll do that to the second graph as well. And that's that. And then now I could also do the x-axis because I have some, what do you call it? Context. So y label, set that equal to toothbrush prices. And then put that in here also. All right. And that's it, right? So really pretty. It's very visually pleasing, and now it's in context with the problem. So on the left, we see the normal distribution of toothbrush prices with a mean of 87 and a standard deviation of 8. And we can see the density, right? We can see the normal distribution. We see that 87 is in the middle. Beautiful. And then on the right, it's the same thing visually, but the only difference is the x-axis. It's a standard normal distribution where the mean is 0 and the standard deviation is 1. Now, where this comes into play is with using z-scores. So when we have, when we're given, we're given the mean, we're given the standard deviation, sometimes, especially like College Board, like if you're in an AP Stat class, they don't want to see you just using that mean and standard deviation. They want to make sure that you know how to convert it into a z-score so that you can use so that they just want to know that you know the z-scores basically. And then when you convert to a z-score, you can no longer use that normal distribution given that mean and standard deviation because you converted those values. And so when you convert it to z-scores, you now are going to have to use a standard normal distribution, which means that the mean is 0 and the standard deviation is 1. And then, but if you notice, whatever those values are, and by the values, I mean values in the middle over here that they're saying like $104.60 and $108.20, those you would convert into z-scores, and then you would have to find the area in between those 2 points using, using the standard normal distribution. And yeah, but it's pretty much all the same thing in Python, in the TI-83, TI-84. All you have to do is just change the values. The only thing that changes would be like your lower bound, your upper bound, from like 104 to whatever the z-score equivalent is. And then you would just change it to make sure that the mean is 0 and the standard deviation is 1, rather than it being 87 and 8. But yeah, I'm so happy I managed to figure it out. Or at least I'm telling you, like, I did this before. Like, I remember reading this before. Like, it's crazy that I just completely forgot about it. I've never experienced something like this. Like, I just, like, absolutely forgot about it. Like, that's, like, crazy. But yeah. Okay. I just can't stop looking at it. It's so nice. All right. So I think that's it, right, for today. I don't really want to go into more depth. I'll do that tomorrow because I have, like, a whole bunch of other stuff to do. But, yep, that's it. So, bye.